Hi everyone. Now we can see blockchain powered cyber risk protection and insurance platform. In this we used Python language, the Flask framework, and Solidity for contracts, and blockchain implementation, HTML, CSS also. Then we use it for machine learning, random forest algorithm, neural networks algorithm, then hybrid also. In this we can see how coding is working like that. So this is the file. First step we have to done training code. This is the ML model is we have separately. This is the training code. So we have data sets. So we are loading the data set. Then we are doing the training of cyber risk prediction. Then we are storing that model files. So that model files we have all models stored in inside ML models. Logistic regression and neural networks and random forest. These were labels we need to display labels mode for that scale up and train the columns, how many columns there like that. So we have CSV file. These are our data sets. So this used to we trained the model. Then we created the models and stored in ML models. Then second step we have to do integration of blockchain. So it is our blockchain solidity code. So we created the address for blockchains and policy for wallet also. In this we then patch used to we are creating the account and private key. Uh, it is our account keys. Then it is our private keys. Then now we will run with the contracts. See if we run contracts file, solidity code will compile. Then it will be stored in a beta.json file. Then contract will happen. So now we deploy that our contracts. If we run contracts that way, it will be compiled bytecode. It will be stored in inside buildings. We have address and wallet. So now we will deploy this our contracts. So for that we have deploy contract support. So it is the Web3 form used to be used for connecting Ganpachi. So this is our address of Ganpachi. Now we will deploy the contracts. So if we run deploy, connected Ganpachi and our address will be get. So now we can run our main code. So in this main code, we are connected the all functions and blockchain integrations. We have in .ini file, and this is our backend key and contact address. So in this, we are loaded the app.py. We used it for SQLite for this project. Instance inside we have the database file. We have models also as well. So it is our model files. It is for users and then for it is a policy checking. And also we connected the three forms. We are set up in contracts and whenever we are running the time it will be deployed and the contracts will create. while doing registration time, while creating the wallet for users. So the time blocks will create. It is the our blockchain address and gas details. So we usually less only for gas price. So if we run register that time, it will be created the register and contracts will blockchains will create. So click on Amazon Pay. It is our main code. If we run, we will get URL. Then we can check our website. So now our backend Ethereum balance is 0. So now we can deploy new one. Okay. So we have to change this one. So all this over. We have to load that contact address and backend key with private key. So again we have to close this one. If we run, we will check that how many balance is there gas value and so now we can check backend balance. It is the other contacts we can use. Without creating contact, it will be reduced. Then again we can use to Canvas use to we can load another one privately into backend key. So we got your we can use to this. You can check our website. So this is our home page of blockchain power cyber risk prevention. Since we have two roles, one is for user and admin. So if we users if we created that time blockchain address we create like wallet address. Then for KYC completion, admin giving to the permission. So we'll check one users. So it will be automatically it will be create address. So if we create is creating. So registration successfully wallet was created on blockchain. So our balance registration transaction fee is done. Then we can check that contact block number is 2, but transaction ID also we can't. And then now we have to log in our admin side. Then we can give validate this user KYC. So this is the admin user. It is the admin dashboard. Now we created this use. When KYC is not verified, if we give verify, it will be KYC verified. So in this we can check now how many policy happen like that, like policy ID coverage and occupation risk score and risk level also we can check. Is the charts. It's based on this one. We created the charts. So now we will check with users. If we log in, we can go to our cyber risk predictions. This is a user profile. Now we don't have any policy. So now we'll do with our predictions. We have data set for this one. Based on that, it will be predict. So now it was the risk level and the risk score also will be displayed in the user, and we can check our policies. That is the coverage of the policy and contact address also. So whenever doing prediction that time also contact will be created. Now we can say that one. Let's see our contact transition ID and the block number was 3, it was created. So before it was created to registering time, then now it was created block number 3. Like prediction time was created. So like this it will be what?